Welcome back for the second part of methods of solution for undetermined coefficient. So we're still solving non-homogeneous equation, so using undetermined coefficient method. So this time around, so we will be solving two additional examples or two additional equations, so which falls under case 2. So recall, so for case 2, that is when the particular solution, or when a term in a particular solution so duplicates those term in the complementary solution, then that it falls under case number 2. And to resolve such equations, so we need to multiply the term, okay, so which is a duplication on the complementary solution, so by x. So until all of the solutions, so both for the particular solution and complementary solutions, are already unique with each other. So going back, so since this is a non-homogeneous equation, so we start so by transforming the derivative into equivalent algebraic function, so m squared minus 6m and then plus 9, so will be equal to 0. And then using our calculator, so let's try to find the roots for the equation. Okay, so that would be polynomial degree 2. So we have 1 for the coefficient of m squared, and then for m it's negative 6, and then for the constant, so that will be 9. And thus, so giving us the first root, so to be equal to 3. And since the second root was not provided, so that means, so this is a repeated root, so giving us m2 to be equivalent to 3 as well. So that's, this one falls under case 2. So our complementary solution then, so will be c1 e raised to 3x, then plus c2, so multiplied it with x, and then e raised to 3x. So that gives us our complementary solution. So c1 e raised to 3x plus c2 x e raised to 3x. So for our particular solution then, so yp, so following the format, so these two terms here are algebraic function, and then the highest exponent or the degree is 2. So thus, so we start with ax squared, so plus bx, and then plus c. And originally, so since we have 3x, so that should be plus e raised to or e times e raised to 3x. But then again, so this term is the same as the first term of the complementary solution. So that's why we're going to multiply it by x. But then if I'm going to multiply it by x, so the next thing that will happen is it will be the same as the second term. So that's why I need to multiply it by another x. So finally, so after doing that, so we're just going to multiply the term, okay, so which is the same as the complementary or the solution for the complementary solution. So thus, I'm going to multiply it by x squared, e raised to 3x. So x squared is no longer the same to any of the two solutions of the complementary solution. So that's our yp is ax squared plus bx plus c plus ex squared e raised to 3x. And this is just the only difference for case 1 and case 2, but the process so will just be the same. Okay, so the process so will just be the same. So we find the second derivative. So yp double prime or yp prime so will be so 2ax then plus b and then plus c is 0. So e then, so x squared e raised to 3x, so using product rule, I'll have u as x squared e raised to 3x, derivative of 3x is 3, and then plus e raised to 3x, and then derivative of x squared is 2x. And thus yp prime then, so would be 2ax plus b, then plus 3e x squared e raised to 3x plus 2e x e raised to 3x. And now, so we need to find the second derivative. So yp double prime then, so will be 2a. Derivative of b will be 0. And then plus, so I'll move out 3e as constant. And then x squared e raised to 3x is the same as the previous ones. I'm just going to copy the term within the parentheses. So which is just 3x squared e raised to 3x plus 2x e raised to 3x. And then plus, so 2e. So we have x e raised to 3x. So that would be a product rule again. So u is x e raised to 3x, its derivative it's 3. Then plus e raised to 3x. So derivative of x is just 1. So yp double prime then, so will be 2a, so plus, so 9e x squared e raised to 3x. So 3e plus 2x, that will be plus 6e x e raised to 3x. Then plus 6e x e raised to 3x, and then plus 2e e raised to 3x as well. So thus giving us, so finally, so for yp double prime then, so will be 2a plus 9e x squared e raised to 3x. So this one is the same, 6e and 6e. So that would be x e raised to 3x. So that would make it 12e x e raised to 3x. And then plus 2e e raised to 3x. So that is our yp double prime. So we have our original equation to be y double prime minus 6y prime. So y double prime minus 6y prime and plus 9y is equals to 6x squared plus 2 minus 12 e raised to 3x. So I'm just going to copy, so yp double prime, so which is this one, paste it here. So for y double prime, and then so we have minus 6. I'll have minus 6, then multiply it with y prime. Our y prime is this. And then for our y, so I'll have plus 9. Y is, okay, so this one, it's not the original one. So the one that we multiplied with x squared. And thus, so this would be equal to the g of x. As we simplify the given term, so that will give us 2a plus 9e x squared e raised to 3x plus 12e x e raised to 3x, so plus 2e e raised to 3x. So we distribute the negative 6, so that would give us negative 12ax, then minus 6b and minus 18e x squared e raised to 3x, and then minus, so 6 times 2e, so we'll have 12e x e raised to 3x, then plus 9ax squared plus 9bx plus 9c, then plus 9e x squared e raised to 3x is equals to 6x squared plus 2 minus 12 e raised to 3x. And from here, so we can combine similar terms. So we have here, so 9e, so this one, x squared e raised to 3x. So this is 9 plus 9 is 18, then minus 18, so that would just cancel out for x squared. So how about x e3x? So the same thing for this, so we'll have 12ex e raised to 3x minus 12ex or e raised to 3x. So leaving us to have that one. Okay, so now that we have that, so we're going to equate. So we're going to equate similar terms. So equate the coefficient, so involving, so I'll start with e raised to 3x. So for e raised to 3x, so we have this one is e raised to 3x. And then we have this as e raised to 3x as well. So from there, so we can write that 2e so 2e is equals to negative 12. And then, so after that, so let's proceed with the term involving x squared. So the term involving x squared is this, x squared, and then this one as well. So thus giving us, so 9a is equals to 6. So the next term, so we have the term involving x. So we have this one, 1. The second one. And we don't have on the right hand side. So it will just be negative 12a plus 9b is equals to 0. So negative 12a plus 9b is equals to 0. And lastly, so we have for the constant. So for the constant, so we have 2a, negative 6b, positive 9c is equals to 2. So we write that one as 2a minus 6b plus 9c is equal to 2. Okay, so again, so we can use our calculator so to solve for the given equations. Although again, you can do it manually if you want. We are going to select 1 for simultaneous equations. So there are 4 variables here, a, b, c, and e. A for x, b for y, and c for z, and then t for e. I'm going to select 4 unknowns. So for the first one, so I don't have a, b, and c. So x, y, z will be 0. and the coefficient of t will be 2, and then the constant is negative 12. For the second equation, so we have a, so which is 9, so for x that is 9, and then 0 for b and c, and even for e. So therefore, we just have the constant, so which is 6. So for the third one, we have 12, negative 12, and then positive 9. So we have 0 for c, and then the constant will just be 0 as well. And finally, so I'll have 2 for a, and then negative 6, and then positive 9. 0 for these, and then 2 for the constant. And we're gonna write the value of a. So a then is equal to 2/3. So b is 8 over 9. C is 2/3. And then our last variable, e, is equivalent to negative 6. And going back for our yp, so again, the yp is the one that was multiplied by x squared, not the original one. So since this is case number 2, so our yp then, so will be, so a is 2/3 x squared, b is 8 over 9x, c is plus 2/3, then e is negative 6 x squared e raised to 3x. And for our general solution, y is equals to yc plus yp. So y then will be equal to, the complementary solution is and we copy yp. So our final solution then, or the general solution, so y is equivalent to c1 e raised to 3x plus c2x e raised to 3x plus 2/3 of x squared plus 8 over 9 of x plus 2/3 minus 6x squared e raised to 3x. And that's how we solve undetermined coefficient or non-homogeneous equation using undetermined coefficient using case 2. So let's have our last example, but this time around, so it's a particular solution. Okay, so we are given an initial value problem, so it's an IVP problem involving higher order differential equations. So we have, this one is m squared, then plus, so that's y, therefore that's not m, so that will be 1, is equals to 0. So from here, so it's obvious, so if I'm going to transpose this one to the left hand side, that would be negative 1. So therefore, m then, so m1, so will be square root of negative 1, that would be positive and negative I. So our alpha, by the way, I use incorrect ink, so that should be in green. So m squared plus 1 is equals to 0. So therefore, our m1, or I'm just going to write m, so to be equivalent to positive and negative I. So giving us the alpha to be 0 and then beta to be positive 1. So that's our complementary solution, then yc, so will just be c1, and then I'll start with cosine, then beta is 1, so that is just cosine x, plus c2 sine x. So that will become our yc. But then for our yp, So yp, so for the first term, so we have 4x. So thus, I'll have ax plus b. But then, so for our second term, so we have 10 sine x. So I'll just have c sine x and then plus e cosine x. That is our yp. So we now find what is yp prime. By the way, it just so happens that the term, so for our yp, is the same as that of our complementary solution. Okay, so we have the sine x is the same as the c2 sine x. E cosine x is the same as the c1 cosine x. So that's why we need to multiply it by x, so giving us to have ax plus b, and then plus cx sine x plus ex cosine x. So that's differentiating our trial particular solution to the complementary solution yc. So for our yp prime, so we derive, so ax will just be a, and then plus c, so product rule, so x sine x, so u is x, derivative of sine x is cosine x. So x sine x, so x cosine x plus sine x. So derivative of x, so that would just be equal to 1. And then for this one, so plus e. So x cosine x, I'll just have e cosine x, its derivative is negative sine x. Then plus cosine x. And that's for our yp prime, so I'll have a plus cx cosine x plus c sine x minus ex sine x, then plus e cosine x. So for our yp double prime then, so a is 0, and I'll have c, so derivative of x cosine x is the same as negative x sine x plus cosine x. And then derivative of sine x will be positive c cosine x. And then minus e, x sine x is x cosine x x cosine x plus sine x. X cosine x plus sine x. And then derivative of cosine x is minus e sine x. So distributing it out, so that will give us negative cx sine x plus c cosine x plus c cosine x minus ex cosine x minus e sine x, then minus e sine x. So finally, for our yp double prime, I'll have negative cx sine x. So I can add the 2 as plus 2c cosine x minus ex cosine x, and minus 2e sine x. So that is our yp double prime. So for our solution then, so I'll have y double prime plus y. So y double prime plus y is equal to, so 4x plus 10 sine x. So 4x plus 10 sine x. So y double prime, I'm just going to copy this. and then plus y plus y. So y would be the one that we multiplied with x. So this will be that one. So I'm just going to add that one. Then is equals to 4x plus 10 sine x. And from here, so we can see that negative cx sine x, so will just be cancelled out with positive cx sine x. So negative x ex cosine x will be cancelled out by positive ex cosine x. And thus, leaving us, so for that equation, and we can equate now. Okay, so we can start equating. So we'll start with probably x. So those that involves x. So we have this one and 4x. So equate coefficient involving x. So we have a is equals to 4. And then those terms involving constant. So which is just b. So the right hand side, so we don't have the constant. So therefore, so b is equals to 0. And then the term, so which involves sine x. So this is the term, so that involves sine x and this one. So thus, we could have negative 2e negative 2e is equals to 10. So thus our e is equal to negative 5. And lastly, for cosine x, so this is the term involving cosine x, and we don't have at the right hand side. So that would give us 2c is equals to 0, and c will be equal to 0. So therefore, so for our yp, or for our particular solutions, I'm going to copy this one. And our yp then, so will be a is 4, so 4x, b is 0, so c is 0 as well, but then e is negative 5. So I'll have negative 5x cosine x. So yp is negative 5, or 4x minus 5x cosine x. So now that we have that, so we're going to write our general solution, so to be yc plus yp. So our yc is given, or it was actually computed, and our yp is this one. So it will be plus. But since this is an initial value problem, so it says here that when x is equals to pi, so y is equals to 0. So that is when x is equals to pi, so y is equals to 0. So I'm going to use that one. So to get for the values of the arbitrary constant C1 and C2. So y is 0. So C1, and then I'll have cosine. X is pi, so cosine pi, plus C2 sine pi. and then plus 4x, so 4 times pi, then minus 5 pi cosine pi. So remember in Cartesian plane, so this, if this 0 degree, this is 90, so this is 180. So pi is equivalent to 180 degrees. So this is the pi. So therefore, the cosine of pi, that is negative 1. Okay, so this one. So this is at negative 1. Positive 1, or 0, I mean. 0 degree, pero the value there, so will be 1. Or you can use the calculator. So cosine pi is negative 1. So cosine pi is negative 1, sine pi is 0, and cosine pi is negative 1. So thus, I'll have 0 is equals to negative C1. So C2 will be 0. So since sine pi is 0, then plus 4 pi. Cosine pi is negative 1 times negative 5 pi. That is 5 plus 5 pi. So transpose C1. So therefore C1 is 9 pi. But then another value is given. That is when x again is pi. So y prime is 2. So that is when x is pi, so y prime is 2. But then what we have here is, so copying the general solution, that is only for y. So what we are given here is y prime. Okay, so y prime is 0, so therefore we need to find what is y prime. So y prime then, so would be equal to, so C1 cosine x, derivative of cosine x is negative C1 sine x. So sine x, that would be plus C2 cosine x. And this would be plus 4. Then minus 5. So x cosine x is product rule. I'll have negative x sine x. And then plus cosine x. And thus y prime, so will be negative C1 sine x plus C2 cosine x plus 4. And then that would be 5x sine x minus 5 cosine x. Plus 5x cosine x minus 5. So that is when y prime is 0. Okay, so negative C1, so sine our x is pi, plus C2 cosine pi, plus 4, plus 5 pi sine pi, minus 5 cosine pi. So sine pi is 0. So sine pi is 0. So this is negative 1. This is negative 1. So thus, so 0 is equals to 0, negative C2. So plus 4. And then negative 5 times negative 1, that would be plus 5. So thus C2 is equals to 9. So finally, so we can now write our equation. So to be C1 is 9 pi. C1 will be C1 is 9 pi cosine x. C2 is 9. Let's keep on moving. So plus 9 sine x. Or C2. Okay, I forgot. So y prime, it's not 0, it's 2. So y prime is 2, so therefore C2 is 7, it's not 9. So C2 will be 7. So 7 sine x. And for our yp, that would be plus 4x minus 5x cosine x. And finally, so that will be our general solution. So the general solution then so will be y is equals to 9 pi cosine x plus 7 sine x plus 4x minus 5x cosine x. And that is how we solve a non-homogeneous equation using methods for undetermined coefficient case 2. Okay. So just a summary, so we need to make sure that the solution for the trial particular solution does not duplicate any of the terms in the complementary solution. So we can prevent that one by multiplying x multiple times. Okay, so until the trial particular solution is no longer the same as that of the complementary solution. And then afterwards, so we just follow the same process for case 1. And that is all about the methods for undetermined coefficient. So have a great day and God bless always.